Okay, remember we're on solving systems of linear equations with two variables. So remember, a system is two equations that has two variables, usually x and y in it. And what we've talked about these systems so far is how to set up some equations given a problem, which is 4.1, and then how to actually start solving them. And the first was by graphing. So what we have done to this point is to figure out the solution to a system. So here's an example, one equation and a second one. Right now, the only way you guys know how to solve is graph each one. You don't have to copy this down. So you would graph each one, whatever they look like. And the solution would be the XY coordinate where they intersect each other. Okay? But that's not very efficient, because sometimes the solution won't be at a nice, neat coordinate. Like it won't be at, say, 1,2 or -4,6. Maybe it'll be at a fraction coordinate. Okay, and that's very hard to read. So leave another way. And the other way, and there's actually two types, is by using algebra. So this is where the algebra skills you learned in grade 9 really come into play. So let's say we have this system and we're asked to solve it using algebra. So we're going to use something called substitution. First thing I'm going to do, okay, to keep track of what I'm doing, is I'm going to number each equation. I'm going to call this equation 1 and this one equation 2. Okay. The next thing I need to do is pick one of the equations and get a variable by itself. So get x by itself or y by itself. Which one, which equation, and which variable looks like it would be easiest to get x or y by itself? Like, if I tried to get x by itself here, I'd have to move this over, then I'd have to divide everything by 3, right? That's a little complicated. Equation 2, getting what by itself? Not y. Why would you get y by itself? Because then you have to move the x over and divide everything by 2. And then you're going to get fractions. Isn't it just easy to get x by itself? Because there's nothing in front of the x. So what we want to do is we want to solve for x in equation 1. What is the one step I need to do to get x by itself? Sorry, in 2. Subtract 2y, correct. Get x by itself in equation 2. So subtract 2y, and I am left with this. Okay. Now remember, I'm looking for values of x and y that work in both equations, so that when I do 3 times the x I find plus 4 times the y I find, it'll equal -4. And the x I find and the y I find times 2 added together will equal 2. Okay? So what I am going to do now is I am going to take this value of x that I found in 2 and plug it in for x in equation 1. Okay? I know that x is 2 minus 2y, so I'm going to put 2 minus 2y here. So I am going to substitute 2 minus 2y for x in equation 1. Why did I do that? Because I'm going to make an equation that has just y's, which means I can solve for y. So when we look at equation 1 now, instead of 3 times x, I'm going to replace the x with this. So it's going to be 3 times 2 minus 2y plus 4y equals negative 4. And like I said, the reason I do that is because now I have an equation that has just y's in it. So can I figure out what y is? And this is equation solving from last year. What's the first thing I do to start solving? Simplify. So let's get rid of the parentheses first. Multiply everything inside by 3, and what do I get? 6 minus 6y, and then plus 4y equals negative 4. Can I keep simplifying? Yeah, I can combine the y's. What's minus 6y plus 4y? Plus 2y, minus 2y, pardon me. Now I can start solving. What do I need to get rid of? 6. The 6. So I got to subtract 6 from both sides. And I get, remember there's still a negative in front of that 2y. Equals negative 10. And what's the last step to get y by itself? Divide by negative 2. And I get y is equal to 5. So I found the y value. Now that I know the y value, how do you think you'd go about finding the x value?
Plug it in.
Yeah, plug it in one of these. It doesn't matter which one. Okay? Because I know that y is now 5. So I can substitute y equals 5 into, and it doesn't matter which equation you substitute it into. I'm going to substitute into 2 because 2 looks like an easier equation. 2 are numbers. Solve for x, and you've got your answer. So I'm going to get x, oh sorry, it's positive 5. It's x plus 2 times, I know y is 5 now, equals 2. And solve that. Well, 2 times 5 is 10. How do I get x by itself? Subtract 10. Subtract 10. And I get x equals negative 8. I've got my 2 answers. And here's how you should write your final answer. You can write it 2 ways. X equals negative 8
y equals 5. Or write it like a coordinate. Because remember, if we were to graph these two,
they would intersect at this point. So you got to know your algebra to do ones like this, okay? That's why we spent a lot of time doing that stuff last year. And if you can check your answers too if you want to. Because if you go back up here,
well, 3 times -8 is -24. 4 times 5 is 20, and -24 plus 20 is -4. And then 5 plus 2 times -8, sorry, -8 plus 2 times 5 is 10, -8 plus 10 is 2, works.
okay, let's look at another one. This one.
So equation 1,
You don't have to write the steps that I write. You don't have to write them. Okay? But it may help. So the first step, pick one of the variables and get it by itself. Which one looks easiest?
2 to get y. So solve for y in number 2. And it's only one step to solve for y. I just subtract 4x from both sides. And I get y equals 5 minus 4x.
Okay?
Now that we've got that y, plug it in for y
Into the other equation. Because then you're going to make an equation that has all x's, which you can solve.
So the first equation, the right equation, sub 5 minus 4x or y in number 1. In which case I can solve for x. So equation 1 now looks like 2x, and instead of y, it's going to be 4 times 5 minus 4x. Equals 7.
Now I want you to try and solve for y.
I want you to, sorry, for x.
Try and figure out what x is by using your knowledge of equation solving. Looks like some people don't have their lessons here or their exercises.
Find everything by negative 4. Yeah.
-1. Yeah.
Yes.
Combine the terms.
Sorry?
Combine the terms.
Yeah. Just 18x. Whoops. So got a minus 20 on that side. Equals 7. Next, Add 20 to both sides. And I get 18x is equal to. Divide both sides by 18. Do not go to decimal.
Leave it as a fraction, but this one can be reduced. 3/2. So we found x. It's 3/2 or 1.5. Okay? What do I do now? Take this 3/2, plug it back into one of them, and figure out what y is, and you've got your answer. I'm going to do equation 2, fewer numbers. So I'm going to sub x equals 3/2 back into equation 2 so I can figure out what y is. What do I get when I do that? I get 4 times 3/2 plus y is equal to 5. Okay, what's next? Don't all jump in at once, it's hard to hear. Combine like terms, there are no like terms to combine.
Times 4 by 3 and
Yeah.
divided by 2.
Clean this baby up.
Remember, 4 is 4/1. So what's 4/1 times 3/2? Completely simplified. 6.
And then subtract 6 from both sides. And I get y is equal to -1.
So I've got my solution.
So x is equal to 3/2, comma y is equal to -1, or 3/2, comma -1.
Either one, you don't have to write both. Okay? So we could have solved that one by graphing, but that would have been hard to see because this is a fraction. How do I know if it's 3/2? It's hard to read on a graph fractions coordinates. Okay, last question because I'm not going to do example 3. How do we use these to solve word problems? So you guys are already familiar with how to set up a system. We now know one algebraic method to solve it so we can tackle problems like this. So first of all, we need to create a system. And here's the situation. Bobby has been saving dimes and quarters to buy a new toy. She has a total of 28 dimes and quarters, and the total value of the coins is $4.30. What are the two unknowns? So the first thing you should do, take the two unknowns and give them variable names. Usually X and Y, but you can pick any letter you want. So just to be a little different, I'm going to pick D and Q. If you do X and Y, it's still right. So how do I take these two and take the information in the question and make two equations? The total number of dimes and quarters is 28.
So what did you do? D plus Q equals 28.
Okay? That's one. The total value of the coins is $4.30. How much is a dime worth? 10 cents. How much is a quarter worth? So the total value of the dimes in cents,
Would be 10D, right?
the total value of the quarters would be 25Y, or I call it Q.
And when I add those together, I get the total value of both of them in cents.
So what should I write? In cents.
CENTS,
430, not
4.30. 4.30 is in dollars.
If I'm going to write these in cents, I've got to write this in cents.
Okay? So we've set up the system. We've done questions like this.
Now we're actually going to go ahead and solve the system.
And right now, the only algebraic way, I mean, we could use graphing, but that would be really hard to graph. You'd need a big grid to graph those.
Okay, so algebra is clearly more efficient.
Get a variable by itself. Which looks easy. Yeah, D or Q, right? Doesn't matter.
So I'm just going to solve, I'm going to solve for D. If you solve for Q, that's fine. So I'm going to solve for D in 1. Which means all I have to do is subtract Q from both sides. And I get D is equal to 28
Times Q.
What do I do with this now?
What do I do with this 28 minus Q? Put it in for D in the other equation, right?
So sub 28 minus Q or D in number 2, the other equation. That will give you an equation that has
Just Q's in it.
So instead of D, I'm going to replace it in parentheses with 28 minus Q. So 10 times 28 minus Q plus 25Q is equal to 430.
Hey, now what? Hello?
Yeah, multiply 10. So 10 times 28 is 280 minus 10Q plus 25Q is equal to 430.
Next.
Collect like terms, yes. Negative 10Q plus 25Q gives me 15Q.
Next.
Subtract 280 from both sides. And I get 15Q is equal to 150. Divide both sides by 15. And I get Q is 10.
So I found the number of quarters. There's 10 of them. Now I just have to find the number of dimes.
So take this answer we just got. Which one do you want to put it into to figure out D?
The first.
Yeah, the first one. So the first one was D plus Q, so D plus 10 is equal to, what was it? 28. Minus 10, minus 10,
15.
D equals 18.
Now, when you solve a problem, you've got to write your final answer in a sentence.
So you want to say there are 10 quarters. And 18 dimes.
And you've solved it. Okay. That last system on the next page involves fractions. I mean, we can do it, but it's overly complicated. We don't need to do it for our purposes. Okay. We've done enough here.